For our next part of reordering, we're going to increase the complexity of our model a little bit, and we're going to have variable demand and variable lead time. So when we have the variability on both demand and lead time, that increases the unknown, increases the uncertainty, and therefore we must increase our reorder point. So it reaches out to cover some of the worst case scenarios, high demand and long lead time. All right, so one way to visualize this is if you think about our demand, we have our normal distribution curve here. Now we also don't know when that order is going to arrive. It could arrive as scheduled, or it could arrive late. And it could arrive late and we could have high demand, so then we're down here. So if you think about visualizing it this way, a longer lead time and a higher demand, rather than ordering to cover there, now we're looking at covering all the way down here where we've got the longer lead time and the higher demand. So we need quite a significant amount of additional quantity to cover that. This is our formula. This is one that I would commit to your notes, obviously. So note that all of these are squared except the first one. That is not a typo. So all of these are squared except the first one. So if you think about this, if you break this down, so it's an average times a standard deviation and an average times the standard deviation. Average lead time times the standard deviation of demand. Average demand times the standard deviation of the lead time. And again, because we're using a square root, we've got to square a bunch of these. So in this example, if our average lead time is 5 days, we just drop our 5 in there. Standard deviation of the lead time, 3 days, goes over here, but that one's squared. Average consumption, right? So our average demand or consumption is 6, goes right there. Again, square that. Standard deviation of that consumption or demand is the 2 right there. And then simply 5 times 4 plus 36 times 9. So we end up with 344, and the z table, the z-score works exactly the same. You'll use that norm.inv. If you're working in Excel, take the square root of 344 times 129, and you get that safety stock of 23.9. Now this functions in the same way. So reorder point, 5 times 6 equals 30. Our average lead time is 5 days. Average demand is 6 units. So that will get us our 50% reorder point. And then on top of that, you'll see this is a significant amount. So on top of that, to get our 90% service level, our Z of 1.29, we will add an additional 23.9 to our 30. Even though our average demand says 30, we are going to order 23 additional, so almost in this case double our reorder point. So we're going to be ordering a lot sooner than we would previously. So again, to review this, so our reorder point of 5 times 6, 30, gets us to that 50% line. Our safety stock gets us that additional 40%, right? And this is our 53.9, gets us that 90%. That last 10%, right? There's a 10% chance of stock out. So ordering at 54 gives us a 10% chance of a stock out occurring. This gives us a 90% service level, 10% stock out. All right, so if we think about this one, you can go ahead and pause it here and work through it if you want. You should have come up with an EOQ of 50. So this is how many we would have to order at each time, right? Our reorder point is 278, but our quantity that we're going to order each time is 50. All right, so in this instance, we're not going to let it get down very low. We're going to order 50 each time. So each time it gets to 278, we're going to be ordering 50. So we should, in theory, never reach that 278.
Sorry, I missed that. Could you say it again, please?
Siri is talking to us here. Okay, here's another one that you can work through. Let me put that back up for a minute. Go ahead and work through that one. And ensure that you are understanding all of these concepts. And then I'm going to again bring up an Excel document here. So again, I've already built a lot of this, but I want to just walk you through how you would build this. So I've got the example here. Z-score calculated the same way. So equals, right, our Z-score times, and then we have square root, and we've got to use the double brackets. So I'll show you why in a minute here. So we've got our average lead time, so we find our average lead time, and again, we do not square this, times our standard deviation of demand, and this is squared. And then we add that to, open another bracket here, our average demand, and again, squared, there's a lot of squaring in this one, times standard deviation of lead time, and this one is squared again. So you can see all of our brackets line up, and we've got to use that double bracket because we're taking the square root of that entire thing. Right? And there we go. So we got the approximately the same answer as we did doing this with a z-table, but there are some variances there. Our reorder point, again, is simply that 5 times 6. We use our z-score from this to get a 90% reorder point of 53.7. And that is it.